So what is a support vector mechanism method? So this is a type of algorithm used for classification of a image or anything else whichever we like, but we are working for a GIS, so that we can say it can be used for image classification. It will separate our image into different categories of a data or things in the data that we have classified. So how does it work? So simply you can look at the image like this is a red dot or green dot. So support vector mechanism method can find a line of separation that is a non-linear line between the different category of a data sets. Means the traditional method can use the linear method, like if x is this one and y is this one, if x is 1, y is 2, if x is 3, then y is 4. But SVM can do it differently. It will create a non-linear space between the different categories of a data point. So these different categories are the classification. So the work of the work of the SVM is to find the line of a separation between the different categories of a data. So SVM find the best way that separate this point by maximizing the distance between the line and the nearest point from each group. The line is called the hyperplane. So feature representation, for a simplicity we can say the two feature like a sand color pixel and amount of a green color pixel in an image. Each image is then represented as a point in a two-dimensional space where one axis represent the sand color and intensity of the other axis represent the green intensity. So in a training phase, the training phase of the data is important. The data we are giving for a training is a pretty important. So we gather a bunch of label images, some label as a desert and some label as a agricultural land. So how the IDM will classify the data at a point of a different labels. So we plot each image in our two-dimensional space and label it accordingly. So imagine there is a drawing of a hyperplane. So these are the different categories defined by the SVM. The SVM try to find the best line that separate desert point from agricultural land point. This line should be maximizing the margin, which is the distance between the line and the nearest point from the each category. So distance from point from this line matters. That class go into which class one. Like there is some pixel in a, let's say I will explain in the next slide. So once we have this line, we can use it to classify the new image. If the new image fall on one side of the line, we will classify as a desert. If it fall on other side, we will classify it an agriculture land. So the thing is that let's say we have an image with lots color of a sand color pixel and a little bit of a green. So what the SVM do at this stage? So in the sand, there is not a pure sand, there is some little bit of green patches that are a very small or reflecting a very small signature. So SVM might classify it as a desert because it fall on the side of hyperplane where desert points are located. So we cannot say all the methods are 100% accurate. So as per if some land use classification is accurate up to 80%, it is acceptable for any government organization project or the real life projects. So we need to maintain the land use land cover accuracy up to 80%.